Hey everyone, my name is Luke, and I'm a bioinformatics analyst and one of the people who built Touchstone Portal. Today, I will give a quick tutorial on how to use this web app, how to access our large spatial transcriptomics technical metrics database, and how to benchmark your own sample using our tools. First and foremost, you can register your account by clicking the register button and register using your .edu or .org email address. Once you're logged in, you can enter into the app. Upon entering the app, you will see a home screen with a dashboard. Here, you can see the number of cells, transcripts, and samples that are currently in our database. Additionally, you can see what tissues, platforms, sample species, sample disease state, and fixation techniques are represented in our dataset in the pie charts below. We can examine this dataset further in the Database Explorer tab. We provided different ways to view our dataset. We have box plots, top quality metrics, and dataset. We will go over each individual option and show what they entail. In box plots, if you click on the drop-down menu, you can see 4 different options for how you want to group the data and compare. For example, by tissue type examines how technical metrics vary across different tissue types. The same applies for panel, dataset, and platform. Now, let's look at top quality metrics. Here, we curated 3 technical metrics that are the most important to examine sample quality: signal-to-noise ratio, cell transcript fraction, and specificity false discovery rate. We only examine these technical metrics within specific tissue types. Here, we have how kidney samples perform on the 3 technical metrics. We can change the tissue type using this drop-down menu. Now we can examine how pancreas performs across the top quality metrics. Next, we look at the metrics page. This page gives us the numerical minimum, maximum, first quartile, third quartile, median, mean, and standard deviation for each technical metric. We can examine these metrics to filter for a given tissue type or a given dataset. Lastly, we can look at the dataset page. Here, we can see every single sample we have in the Spatial Touchstone and public dataset, along with their sample ID, platform, tissue type, dataset, panel, species, and source. The sample ID can be used in the query function, which I will be showing later. Furthermore, the source also contains the geo-ascension number for the data. Going back to the home page, we are going to go to the Submit Sample tab to show how you can submit your own sample into this database and benchmark the quality of your sample. Before you can submit your sample, you must fill out the following fields. For sample ID, come up with a unique sample ID and make sure to record it. The sample ID will be the identifier for your sample and is what is needed to query your sample later on. Then you can submit your platform using the drop-down menu. Currently, our tool supports Cosmix and Xenium. In the panel drop-down menu, select your panel. If you use the custom panel, select the custom panel option and input your panel size using the field below. Next, enter your species, fixation technique, tissue type, and disease type. In our example, we're going to submit a Cosmix appendix sample. Once everything is filled out, upload your files. Please consult the FAQ section for the exact file type to upload, given your platform. Select the files you wish to upload and click the upload buttons to complete the upload. After the upload is completed, click on Submit. Upon the completion of the technical metrics calculations, you will be directed to this Operation Success page, where you can determine how your sample is benchmarked against historical data. Alternatively, you can reach the Operation Success page by going to the Query by ID tab. Enter the sample ID of your sample into the field and click Search. Here, you can see the sample ID above. We have some of the same visualizations as before in the Database Explorer, such as box plots, top quality metrics, and metrics. After the submission or query, you gain access to additional visualizations such as bar plots and all quality metrics. We will examine all visualizations after submitting a sample or query. Let's revisit box plots. You can now see that your sample is indicated by a red dot, and the value of your technical metric is highlighted using this purple dashed line. You may recall that the sample we submitted was an appendix tissue, and that the red dot indeed lands on the appendix box in this graph. For top quality metrics, we can see that the only tissue type being visualized is the one submitted. Here, the red dot indicates the metric value of your sample of interest. Lastly, for the metrics, here you can see that in addition to the statistics of each metric, your sample's metric value is shown in blue text at the bottom of each metric. Now, we will explore the new visualizations. First, we will look at bar plots. Here, we have another way to examine how your sample compares against other samples by using bar plots. In this visualization, your sample's technical metric values are shown using a dashed red line. Currently, the bar plots are colored based on the tissue type. However, it can be easily switched to panel, dataset, or platform. Let's move on to all quality metrics. Similar to top quality metrics, all quality metrics is subsetted for the tissue type of your sample, and we use the three metrics we believe are the most important to examine your sample quality: signal-to-noise ratio, cell transcript fraction, and specificity false discovery rate. Although here, the metrics are compared using bar plots to see the individual differences. Similar to other visualizations, a dashed red line represents the value of your sample's metrics. And that concludes the tutorial for our Spatial Touchstone portal. We also have an FAQ section which may answer questions about the tool that you may have. For any additional inquiries, please feel free to reach out to us at spatialtouchstone@stjude.org. Thank you for watching, and we hope that this is a tool that will be useful for your spatial transcriptomics studies.